Hello viewers, welcome to EduFlux. In this series, we are providing solution to the problems which we provide in our Telegram quiz that we conduct in every week. Now, what was today's problem? Today's problem was we had a capacitor, we had another capacitor and the capacitor connected like this, and the capacitors were connected to a black box. The capacitors were connected to a black box. Now, the value of the capacitors were, this is 3 microfarad and this is 6 microfarad. And the voltage were, say this is 4 volt and this is 6 volt. Now, it was said that the current through the capacitor, there was a switch, and as the switch was closed, the current through the capacitor was given by the expression 20 e to the power minus t. Now, what we have to do here is that we have to at first identify. Now we were asked to find out the energy delivered to the load and the energy trapped in the capacitor. These were the two questions. It was a common data question. Now see, we have to identify the black box. What is the black box? First of all, let's focus on the current equation. What will happen if I plot the current equation? Let's say I'm plotting current with time. This is t and this is I. See, at t is equal to 0, the value of I is 20 and it is exponentially decaying and the time constant is 1. This much we know from our knowledge of transient. So, what can be the black box? Now this is intuition. You have to have a very good knowledge on transient, then you can do it on spot. What can be the black box? Through which the current supplied by the capacitor, that will decrease like this. And many of you have done it correctly. The black box is nothing but a resistance. Say it's R. The black box is nothing but a resistance. Okay. Let's see now. Now our problem becomes a little bit simple. We have identified the black box, the element in the black box. Now, here it is 4 volt and here it is 6 volt. This is before the switch was closed. This is open actually. This switch is now open. Now, and this is 3 microfarad. This is 6 microfarad. Now I am closing the switch. What is the initial current that is flowing? The initial current I naught, I can say from my property of transient, that will be just 6 plus 4 by R, because the initial voltage the capacitor is giving, the capacitor is having a charge of 4 volt and here also 6 volt, and initially the capacitor will act as short circuit, but the charge is there, so due to the charge some voltage also there, initially it will not behave as short circuit here, that it will not give voltage 0, but it is having the charge and that charge will start decaying. So I can say that this initial voltage will appear across the resistor initially. So at I0 that will be 6 plus 4, that is 10 by R. And also from the expression of IT that is given already to us, 20 e to the power minus t. From there, if I calculate I0, I will get here I0 will be 20. So 10 by R will be 20, implies that we can get here R is equal to 0.5 ohm. So we have already calculated our R, that is 0.5 ohm. Now we have to calculate the energy delivered to the load. The first question is energy delivered to the load. See, we have I is equal to IT, that is 20 e to the power minus t ampere. We have resistance is equal to, or we have found out, that is 0.5. It is 0.5 mega ohm. Because it is 0.5 mega ohm because the voltage is 6 plus 4 R, that is 10 R, and the current was 20 microampere. The current, that is not ampere, it is 20 microampere in the question. Please correct it. The resistance is 0.5 mega ohm, micro and mega. Now let's confirm that it is resistance or not. How to confirm? See, 20 e to the power minus t by tau. This tau is the time constant, and see, both the resistances are in series. Why they are in series? They are in series because one end is connected to the other end, but the other two ends are free, so they are in series. This is my 3 microfarad resistance, this is my 6 microfarad resistance. This 3 and 6 microfarad resistances, this together will become 2 microfarad resistances. 3 into 6 by 3 plus 6, that is 2 microfarad resistance. Now, so tau is equal to RC, so 2 into 0.5, that gives 1. Micro and mega will, this micro and this mega will cancel, so 1 second. So now it is t is equal to 1, so our calculation is correct, our assumption is correct that it is it's a resistance. Now, energy delivered to the load. Let's forget that there are capacitors. I am showing you one way to do the problem. I will show you the other way also. That will be an easier way, but let me deal with the conventional problem. See, we have identified that R is 0.5 mega ohm. Now, what is in time dt? What is the energy? Energy will be I square, I is a function of t, R dt. Now, let's replace I square. What is I? I is my 20 e to the power minus t into 10 to the power minus 6 ampere. What is R? R is 0.5 into 10 to the power 6 dt. And we'll integrate this from, if t is equal to 0, there is no dissipation, no power delivered to the load. At t is equal to t, u is u. So I can say u is equal to, if I solve this equation, I am not showing the solution. I think everybody can do this integral. This is a very simple integral. The answer comes out to be 100 microjoule. The answer comes out to be 100 microjoule. Now, let's see what is exactly happening. See, I am drawing the resistance. This is the capacitor and this is the resistance. Now I am just switching. Now just see, I am redrawing it. This is say plus minus. It was having say 4 volt. This was having 6 volt. This is 3 microfarad. This is 6 microfarad, and this is my 0.5 mega ohm. Now I will redraw this like this. After I close the switch, just see it properly. After I close the switch, what is happening? After I close the switch, this circuit now becomes like this. Now, just see here. This is my plus 4 volt, but this one I am just bringing this resistance, or let me do here this part. Let me delete this. This is my plus 4 volt. This is a plus 6 volt. This is, and this is my resistance. Now, this is my plus 6 volt, and this is 6 microfarad. This is 3 microfarad. This is 3, this is 6, this is plus, this is minus, and this is 4 volt. Now, and this is R, and R is 0.5 mega ohm. Now, what will I do here? See, these two will be coming at the same potential, because at the end, what will happen? At the end, if I apply KVL, actually now these two are in parallel connection, I can say. If I can ignore this resistance for some time, then I can assume that this is in parallel connection. Now, why am I ignoring the resistance? Now you will ask me, there is a resistance, why am I ignoring the resistance? I should not ignore the resistance. Yes, I should not ignore the resistance, but when the current will stop flowing, after the charge distribution happens, when the current will stop flowing, we have to understand that these two will be in the same potential. These two will be in the same potential. So effectively this resistance won't have any effect. Now let's see here. Now let me show you the charge is conserved. See, actually what is happening here, these two plates, this plate of this capacitor and this plate of this capacitor are an isolated system, and these two plates are in an isolated system. So there is no drain or there is no source of charge. So charge is conserved. So I can say total Q is Q1 plus Q2, and after connecting, at steady state, both will be at same potential, same voltage. Now why? Now you may ask why both are at same potential. See, I already told you why I am telling parallel connection, because both are in same potential, that's why. You can argue that this resistance is there, then how they are in parallel? Why will I take parallel? But see, this I is 0 at steady state, and the charge distribution is such that the I is 0. And now if I say this is V1, if I say this is V2, what I can write, V1 minus 0 into R is equal to V2. So V1 will be equal to V2. I think this much explanation is clear. Now Q is equal to Q1 plus Q2. Now just see Q. In what is Q? I can say Q is equal to Q1 dash plus Q2 dash, or say, let's say the equivalent resistance, this is Q1 dash and this Q2 dash. So Q1 dash plus Q2 dash is Q1 plus Q2. Now this Q1 dash, that is C1 into V, because both voltages will be at V. I told you V1 dash will be equal to V2 dash, I showed you already. Now C2 into V will be C1 V1 plus C2 V2. From here I can write V is equal to C1 V1 plus C2 V2 divided by here C1 plus C2. C1 plus C2. Now I will be using this formula to write my equation. Now let's look at our situation here. This is plus 6 volt and this is 6 microfarad. This is 6 volt, this is 6 microfarad, and this is plus and this is minus. If you look at carefully, this plus is connected to the minus one. So this is plus, this is minus, and this is our, say, what volt? This is at 4 volt, and this is 3 microfarad. Now I will write here V, the final potential, that is C1 V1. What is C1? C1 is 6. I will write in microfarad only. Microfarad will cancel. 6 plus into 6 plus, see here, 3 C2 V2. V2 will be minus 4 because it is in the opposite polarity, divided by 6 plus 3. So after solving this, I will be getting V as minus 24 to minus 12 plus 36, that is minus 24 by 9 volt. So now it is asked what is the energy trapped. That means after redistribution, the remaining charge, what remaining charge, it will be plus Q1 dash, this will be plus Q2 dash. So that much charge it will remain. So the remaining charge, that means the charge which is already remaining in the capacitor, that will be half. Now the capacitors are in parallel combination, so I have to say half C1 plus C2 into V square. Half C1 plus C2 into V square. If you do this, half into, let me do here, half into C1 plus C2 is 6 plus 3 into V square. V square is minus 24 by 9 whole square. I will be getting my answer as 32 microjoule. This C1, this 6 plus 3 is in microfarad, so I am getting in microjoule, 32. Okay, let me show you another method now. Just look at this. I have got my answers as 100 microjoule and 32 microjoule, but I can do it very easily without identifying the element also. But I have to identify the element without doing this integration part and all. See, initially my this was say my voltage was here 4 volt, and here it was 6 volt, and here it was 3 microfarad, and here it was 6 microfarad. Now initially what was the energy U1? Half C1 V1 square plus half C2 V2 square. If I do half C1 V1 square, that is 3 into 4 square, and half C2 V2 square 6 into 6 square. If I do this, I will get my answer as 132 microjoule. You can do it by yourself. Now already we found out that after redistribution, the energy trapped, that is 32 microjoule. The remaining amount of energy will be delivered to the load, that is 132 minus 32, that is 100 microjoule. So this is as simple as that. But for the last method which I am showing, you have to have a very good idea about the circuit and about the element. Just looking at the current, you have to understand that this is a resistance, and it is the capacitors are actually getting, the charge is getting redistributed. So what we have learned from this video, that is by identifying the element, we can easily solve the question, because if we know the property of the capacitor, that is the conservation of charge law and all, if we apply them, any question can be dealt in a simple manner. So that's all for this video. If you like our content, then please share this, please subscribe to our channel and share this video, and please join our Telegram group for regular quizzes and doubt discussion. Thank you.